we're in section 5.3, identifying proportional relationships. So this really comes on the heels of ratios and rates for a reason, because proportions are made up of ratios, two ratios that are equal to each other. So a proportion sets two ratios equivalent to each other. I know that that they are equivalent because I can reduce them to simplest form and they're the same fraction. 2/3 is equivalent to 4/6. All right. Another method that we're going to learn today is a method called cross products. We've actually touched on this in a previous lesson, but cross products basically say that I can take the variables that are diagonal from each other, A and D, and I can multiply them together. All right, and the same thing goes for B and C. So I can go B and C, and I can multiply them together, and I can set them equal to each other in an equation. All right, that's cross products. All right, so in example 1, I need to tell whether the ratios form a proportion. Examples 1 and 2 are the same thing, except it's just different methods. So your homework does not say you have to use this method or you have to use the other method. You can use whichever one you choose once we do both. Okay? So the first method, and really both of them, take the ratio and you put it into a fraction. So we have 6/4, which becomes what as a fraction? 6/4. And 8/12 becomes 8/12. All right, now you need to reduce them to simplest form. If they're the same fraction, it's yes. If they're not the same fraction, it's no. Okay, so 6/4 reduces to? No. Leave it in proper. 3/2. As soon as, okay, so I heard 1.5. As soon as you make this a mixed number, it's not a ratio anymore. Now you're not comparing 3 to 2. Now you've changed it to a mixed number, so never change ratios to mixed numbers. All right, just leave them in proper. So 3/2 and 8/12 reduces to 2/3. Is that the same fraction? No. Okay, so you say 3/2 does not equal 2/3, and no. So you show them reduced, and you say no. Okay? All right, so let's do the next one now. All right, 10 to 40 and 2.5 to 10. I want you to simplify those fractions and tell me whether or not they're equivalent. Okay, so this one, 10/40, I don't think anybody has a problem reducing that to 1/4, right? Now, 2.5/10, I see some people kind of struggling with that a little bit because of the decimal. Now, this is what your book suggests. I don't hate this, idea of getting rid of your decimal. So how could I get rid of my decimal here? Does anybody have an idea, Isaiah? I could.
You could probably move the decimal to the right one.
If I multiply top and bottom by 10, because I have one decimal place, the tenths place, it becomes 25/100. Okay, and then now it's a lot easier to see that what would that reduce to? 1/4. Okay, now you are allowed to use your calculators. If you do 2.5/10 and you reduce it, you get 1/4. Okay, so this work is not required to show. However, it is important that you understand, how you got there in the first place. Okay, and I think that does help it be a little more clear. So 1/4 and 1/4, so your answer is yes. Your answer is yes, they are equivalent. Right, so obviously, we run into some issues when we have decimals. So that's why I am going to kind of push you more towards what we do in example 2, and that is cross products. But before we get into cross products, let's look at fractions. Okay? When I have 1/2 to 1/4 and 8 to 4. So now, again, anytime these fractions or decimals are in the mix, it becomes a little bit more like, how do I solve this? Well, I still use the same process where I would say 1/2 divided by 1/4. I'm just dividing a fraction by a fraction, which, guys, is the same thing as 1/2 divided by 1/4. Yes, which is equal to 1/2 times 4/1, which is 2. So now, if the second ratio is equivalent to 2, then I know they're equivalent. All right? I just needed to show you one where you have a fraction over a fraction because that's a little different. All right? So I'm trying to show you all the different possibilities. All right? So what is 8 divided by 4, guys? 2. So since both answers are 2, my answer is yes. I'm sorry, both ratios. The value of the ratio. All right, so moving on to example 2. Example 2 runs parallel to example 1. What do I mean by that? I mean that it doesn't matter which method you use. In your homework it says tell whether or not they're equivalent. Okay, so you really can choose whichever method you want. You can reduce the fractions or you can use cross products, and here's how we do it. We need to take both ratios and put them into fractions and set them equal to each other. Set them equal to each other. So we have 6/9. So we go 6 over 9. And we have 12 over 18. The order is still important, okay? All right, and then cross products say that I take the terms diagonal from each other and I multiply them. 6 times 18 and 9 times 12. If they are equal, then it's a proportion. If they are not the same number, then it's not a proportion. I can't stop here. You need to write the total. What is 6 times 18? 108. What is 9 times 12? So it's yes. Now, decimals don't matter. Fractions don't matter. All right, that's why I really lean towards cross products because it kind of takes a lot of that guesswork out as far as, you know, the decimal points messing us up and whatnot. All right, I want you to go ahead and test the second proportion, 2/3 to 4/5. All right, just go ahead and test it using your cross products. All right, so 2/3 to 4/5. Well, what's 2 times 5?
10.
Okay, what's 3 times 4?
12.
No. Okay, so cross products, again, cross products is a really easy way to tell whether or not two ratios form a proportion. Now, this should look familiar to you. What is this? This is a ratio table. It is a ratio table. But are there any values that are blank? No. So in 5.1 and 5.2, I needed to complete a ratio table. In section 5.3, they give me a ratio table, but just because each of these quantities are ratios does not mean that they are proportionate. In order to be proportionate, their values must all be the same. So I need to find the value of each ratio and see if it's the same. Okay? How do I do that? How do I find the value of a ratio?
By dividing.
Divide the top quantity divided by the bottom quantity. Okay? So that's exactly what we're going to do. What is 1/2 divided by 3?
1/6.
It is 1/6. Okay, well, guys, let's not overthink this here. 1/6. Okay, all right, there's nothing to do here. 1/6 reduces to 1/6. All right, so we're good for the first two. But we can't stop here. We have to test every single ratio. One of them might mess it up. I'm not going to know until I do all four. 3/2 divided by 9.
1/6.
3/2 divided by 9, if you were to test that, it is 1/6. 2/12, what does that reduce to? 1/6. So because all of the values, you're basically adding a third row here. Because all of the values are 1/6, it is a proportional relationship. Okay, you see that? They're all 1/6. All right, go ahead and test it on the bottom one. All right, so you're basically adding a third row to the bottom. In 5.1 and 5.2, we put value in the middle. If you did that, that's fine. Okay. but you're just figuring out what are the values for each ratio. And guys, you do need to set this up on all of them. You need to fill in all the values. So what is 2/4 reduced? 1/2. Okay. So now the rest of them have to be 1/2 in order to be proportionate. Okay. Well, what's 4/2? 2/1. What's 6/1? 6/1. What is? Hold on. Yeah, and then I have 16/1. Goodness. This is like way off. Okay, it's like so obvious. It's not proportionate. Okay, so on your quiz, it might not be as obvious. There might only be one that's off. But they all have to be, guys, please listen. They all have to be the same value to be proportionate. Okay, so my answer is clearly no. All right, we have one more example. Okay, in example 4, I say one more example, but we're doing 2 of these. Okay, in example 4, it wants us to compare basically a rate. We're finding a rate, and we're making a comparison. It says you swim 20 laps in 16 minutes. Of the total laps swam, 16 minutes, you completed your first 4 laps in 2.4 minutes. Are these rates proportional, and about how long do you think it would take you to swim 10 laps? All right, so let's go ahead and find our rate for both of these ratios. So 20 laps, and that's a little confusing because we actually need to know, we're going to put minutes over laps. You just have to trust me on that. I think I might have worded that wrong because you want to know how many laps per minute. Okay, so that's why the time needs to be on the bottom. All right, so 16 laps in 20 minutes, and then we're going to go 2.4 laps in 4 minutes, and I need to find each rate. All right, so go ahead and do that. How many laps per minute is what I'm looking for. Oh, wait, hold on. Hold on. Did I do that wrong? Hold on. 2.4, it's minutes. No. It's minutes over laps. I'm sorry. I just said that wrong. I'm sorry. It's been a long day. This is how you should write it. It's minutes over laps. And I did it for both. Okay. Minutes over laps, that's fine. I know. I just totally messed that up. I'm sorry. Okay. We'll get it. All right. We're going to get to the answer. All right. 16 divided by 20 is what? 4/5, but as a decimal, you could say it as a fraction, 4/5 of a minute, or 0.8 of a minute. I kind of like 4/5. 4/5 of a minute. And we'll talk about how many seconds that is in a second per lap. Okay. What is it for the other one?
3/5 or 0.6.
Okay, 3/5 or 0.6. 3/5 minutes per lap. Okay, so what do you notice? All right, are these ratios proportionate? Are they proportionate? They're both simplified. One is 4/5, the other one is 3/5. So they're not proportionate. Why do you think they would not be proportionate? You're the same person. Why are your first 4 laps actually a little faster than all of your laps total? Because you're going to get tired, right? Unless you're Michael Phelps or something, right? Okay, so what I see here is that 2 rates are not proportionate, but I have to use these values to try to figure out, well, I'm not doing short distance, but I'm not doing the full long distance either. So about how many minutes do you think it would take to run 10 laps? Okay, well, let's go worst case scenario. If you're going at this rate, okay, what's 4/5 times 10? How many minutes would it take? 4/5 of a minute.
8 minutes.
It would take 8 minutes. Okay, you just multiply them. So worst case scenario, if you're going like the speed of when you're the most tired, okay, it would take you 8 minutes. If you're going your fastest speed, it would take 6 minutes. So probably, because 10 is kind of in the middle, it's probably going to take you maybe about 7 minutes to do 10 laps. But you're basically guessing at this point, okay? So this is an estimate based on the fact that my times are not proportionate, meaning that I get tired, I'm human, okay? So some of that comes into play. I'm not a huge fan of this example, but I think that we can, kind of benefit from it in terms of I can see that two rates are not equivalent, but I can use it to make a guess, and I'm going to say about 7 minutes for 10 laps. For 10 laps. Okay, somewhere in between for that mid-distance. All right, how many seconds is 4/5 of a minute? Just curious. This really doesn't have anything to do with the problem. How many seconds would it be, Kyle? 4/5. So if there's 60 seconds in a minute, I can divide it by 5 because of fifth. And so there's 12 seconds per fifth, which 12 times 4 is 48. So 48 seconds, and then it would be 36 seconds. All right, that was just a little extra. All right, I put another problem in here. This is actually very similar to the last 3 problems on your homework, okay? And this is similar to a problem I would put on a quiz or a test, okay? Where you need to set up a proportion. Are you listening? You need to set up a proportion. You do 120 sit-ups in 3 minutes, and your friend does 148 sit-ups in 3.5 minutes. Do these rates form a proportion? And explain. Your explanation is your work, okay? So you can't just say yes or no. All right? So the first thing I need to do is set up a proportion for my first ratio. Technically, it doesn't matter the order as long as the other one matches. I like to just write it in the order that I read it. 120 over 3. Okay? So if I do sit-ups over minutes on the left side, what do you think the right side needs to say? Sit-ups over minutes. Okay? That's about the only way you can mess this up. And I say that in the most loving way possible. Okay? Yeah, I mean, it happens. It happens. Hopefully it won't. But so on the other side, I say 148 over 3.5. Now, technically, there are 2 ways you can do this. You can reduce each ratio and see if they simplify to be the same fraction. I would not recommend that. I would recommend cross products. Cross products. Go ahead and do your cross products. 120 times 3.5 and 148 times 3. If they come out to be the same number, then they are proportionate. If they don't, then they're not. Yes.
How do you know it's cross multiply?
To reduce, you can do either one, but I would cross multiply for sure.
For all of them?
For all of them.
Oh, I was cross multiply.
If it says, do they form a proportion, I would cross multiply to solve. All right. What's 120 times 3.5? 420. And the other one? Do they equal? Nope. All right. And again, that's how you do the last 3 problems on your homework tonight. All right. If you understand that, this is everything you need to know for section 5.3.